moderating this panel this afternoon, which is great because I get to ask difficult questions and not answer them. But really theme-wise, what we're doing in this session is talking about what are these advanced networks for in the first place? What need the energy and sort of measures of consistency amongst the KPIs that we're dealing with? And then there's a whole new set of things which are being called value indicators, things like sustainability, safety, trust, inclusion, security, resilience. I could go on, and we will go. So I really want our panelists to help us understand how those wider set of goals for society, for the economy, for individual customers are going to translate into the way that we design and build and innovate in these networks. And it should be that we're informed in that process by the experience of 5G, right? What can we learn from 5G that will take us into the 6G era? And I say 6G era very advisedly, because even just a couple of years ago, I think researchers are like, all of my research ideas will fit in this bucket called 6G. That's the future. Today, we're starting to crystallize what 6G actually is in a 3GPP context. And it is some of those things, but it's definitely not all of them. So we need to think about, a time period in the future where 6G is actually just one of the advanced networks that we're binding together. But we are thinking about a network of networks that pulls all of these things together in a wider sense to deliver on some of these KPIs, KVIs, etc. So with that as the sort of landscape that we're occupying for the next little while, I'd like to have our panelists introduce themselves in just a couple of sentences, their role and their key interest in these topics. And I'll start with Doug over here.
Hi, I'm Doug Pulley. I am CTO and co-founder of RAN Semi. RAN Semi does semiconductors for the RAN, so no surprises there. So we do chips for base stations, and I've been doing chips for base stations for almost forever, it seems now. And for my sins, in addition, I also chair the UK TIN AI Expert Working Group on AI in telecoms.
Thank you, Doug. And it has been said that there are too many Simons in telecoms. I think there are just the right number. What do you think, Simon?
On this instance, I think there is, yes. So I'm Simon Burley, so I'm the Director of Technology within the Communications, Networks and Communications Group within Ofcom, which is the independent communications regulator for the UK.
Thanks, Simon. And making a stand for us here is Julie.
Hi, Dinal. I'm Julie McCann. I'm co-director of Space, Telecoms and Security for Imperial College. And I'm very lucky. If you've seen on the front of your magazine, there's the Federated Telecoms Hubs, of which there are 4 entities. I'm lucky to head up one of those entities, which is called Cheddar.
Thanks, Julie. And Ian.
Thank you, Simon. Ian Smith. I'm the head of UK TIN, Telecommunications Innovation Network. I've been in telecoms for a very long time, so I've worked for operators, I've worked for vendors, I've worked for government, I've worked as a CTO in an altnet, and now I'm back sort of working and heading up UK TIN. So I've been around the block a bit.
Yeah, very, very much an ecosystem player, Ian, and we'll return to the ecosystem theme. So I've got just a handful of sort of broad questions that I'm going to invite our panelists to comment on, but I want to get a lot of input from yourselves in the audience, questions for them and so on, to keep them on their toes. So I want to start with where I finished off in that introduction around the fact that we should really know a lot of things about how to build these future networks, coming from the vast investment that we've had in existing networks, most currently 5G. Are we getting those learnings, Doug? And how do we translate them into the next decade?
Right, I think you've hit the nail on the head with the word vast. What I would perceive, and certainly from somebody who has to embody the standard in a chip that goes into a base station, simplification is, I think, the thing we should learn from previous generations. I mean, the 5G specs are very much, they're not even a menu anymore, they're a list of ingredients, and basically I'd like to, make standards decisive again. I'd like them to choose exactly what they want rather than a plethora of bits and pieces, because it then falls on to those people building equipment to actually choose which bits to put in. If there's far too many bits, it takes a long time to test them, to develop them, to interoperate them. So it adds cost or development time, cost of capital equipment when operators buy it. It costs money to operate it. It just percolates the entire supply chain. So I think simplification of standards, focusing on doing what we do best, do more of less, would be, I think, my
very
takeaway.
Very much a less is more message there. Is that going to happen though, Doug? I mean, I don't see 3GPP going, it's okay, we won't have that.
Well, I heard, and it was quoted to me that last week or the week before in Incheon that the 3GPP folks did actually acknowledge the problem. And as we all know, acknowledgement is the first step to recovery.
Thanks, Doug. So, I mean, that's very much in terms of what's inside the box for 5G. But Simon, in terms of what 5G networks are delivering and how to deliver future networks to learn from that, what's your perspective?
Yeah, I think from a 5G perspective, I think some of the key sort of benefits that it has brought, obviously it's brought new and additional spectrum in terms of C-band. It's brought along massive MIMO as well as an antenna technology. And I think also as well, the notion of disaggregation and service-based architectures, I think all of these collectively form the enablers for delivering networks of the future that can deliver higher levels of performance, more capacity, etc. But I think there is, like I said, these are the enablers, I think, for the way forward. So I think, when it comes to 6G, I think one of the things that we probably need to be mindful of is in terms of the use cases that were sort of set out for 5G, and I think that really was, if there was an example of, an example to attribute to the hype cycle, I think 5G is probably a good example there in terms of the hype that was set up for it, in terms of the use cases, etc., that it would deliver. But the problem, though, is that 5G has been rolled out essentially in two phases. We have the non-standalone variant, which is what has been sort of rolled out today to help speed up that process of delivering 5G out to the market. But in terms of unlocking those use cases, a lot of those use cases were dependent on a 5G core network. So those ultra, reliable, low latency applications, etc., required a standalone architecture, which is only now just starting, to make its presence in the marketplace. So I think when it comes to 6G, it's sort of a more sort of pragmatic sort of understanding, the types of services and evolving the types of services that are important to people today and how they will evolve into the future, building that platform so that those technology enablers are sort of phased in at the right time to deliver on those use cases that are going to be important and key is probably something that we need to think about.
Right, and my understanding from the workshop Doug was mentioned is that there's a pretty clear consensus that two-phase version of 5G is not the way to go for the future, right?
I think there's certainly lessons to be learnt from that in terms of then how you sort of set up, the expectations and the types of capabilities that we deliver. Maybe it's more about there's an aspect of the messaging as well in terms of setting those expectations to the industry and also, the wider economy, etc. I mean, we've all heard how 5G is going to transform our lives, generate economic growth, etc. So there's messaging aspects, I think, associated with this as well.
So you mean when you've got that 5G indicator on your phone, you don't feel the socio-economic benefit flowing through you?
Not at the moment, I guess.
Right, there we are. Ian, what do you think we've learned from 5G that we can take forward?
I think we've learnt a huge amount from 5G, and I agree with what Doug's hit the nail on the head about simplifying things, because it's insanely complex. And I did chuckle when you're talking about those KPIs, because back in my network operator days, those KPIs were very, very important to me. And they're still important to everybody, and they don't go away. What's happened is we've layered on more and more complexity into these networks, more and more KPIs to manage. And the last time I looked at it, when I was doing EE and 3s under the MBNL stuff, there was something like every day we produced a spreadsheet, well, not a spreadsheet, it was a format report at 120 pages tracking about 400 different KPIs. Now, if that's not complex and insanity, I don't know what is. So we really need to try to extract from that and make it much more simple. I think later on we're going to come on and talk about operations and things in networks, but it is really difficult from an operator perspective. And listening to the panel this morning, just before the lunch session, where we're talking about operators and their procurement cycles and how difficult it is. I think there's a reason we've learned from 5G, and it's that split between standalone and new radio. In that the operators who've got these networks have gone for the easy, cheapest option, which is to put 5G new radio onto a 4G network, and that's it. To build a 5G network, standalone, you've got to build a new core. New core complexity again, it comes with cost. So what we need to do is when we move to 6G is find a way we can have an evolution path that means we can just continue the work that's going on when we've got to 5G SA, that you can put 6G on it without having to re-architect your network. And most importantly, and this is the hard bit, if you're an operator, how do you get rid of your legacy? So how can we take those 2G, 3G services off, get rid of all that old infrastructure and move the thing forward so we evolve? And I had an interesting conversation with equipment provider back with my 5G days, and I said to them, can you come and do stuff in the UK, please? Can we have another provider? And they said, well, we could, but we don't do 2G or 3G. We don't develop that technology anymore. So it immediately excluded them as an opportunity to grow our sort of vendor base and the supply chain. So I think it comes back to simplify it.
Yeah.
I've got to make it much simpler, much more obvious, much more way to evolve what we've got and grow it, and sort of the development cycles where we just bolt things on rather than have to re-architect all the time.
The weight of the legacy. And the legacy comes with weight in more ways than one. 4G and still 5G was still a pile of boxes. And I suspect, Julie, you'd be more of a software mentality in future networks.
Absolutely. So I think I am an odd person in the panel today, because I don't even, on many different levels, but I don't come from the 5G world at all. I represent that new sort of 6G outlook that has, the machine learning, the open source, the very agile systems, and yes, so it's softwarization could help. Complexity, machine learning, AI and so on eats complexity for breakfast. That's why we need those. I don't normally advocate using something when it's not needed, but this is where it's needed.
I agree.
And I think those tools are where we can help with some of this transition and to bring on the new research that we're all doing.
Yeah, very good. So lots of lessons to learn from 5G. Just one aspect that maybe didn't come out that I was expecting is so you'll remember, or pretty much the gentleman on the panel, you've declared yourself as not having come from that background, Julie, will remember the 3G era, where we called 3G for a while UMTS, and the U stood for universal. It was going to be everything to anybody. It was going to eat up satellite. It was going to eat up PMR and all of that sort of thing. Yeah. It didn't, needless to say. And I wonder if there isn't also a lesson from 5G about not expecting a network to be all things to all people.
Well, what was 4G called? LTE, long-term evolution.
Long-term
so again,
evolution.
we've gone back to Gs rather than we've got this great idea about evolving stuff, but we keep having Gs which drive a whole new world of something.
Yeah.
So Ian, to double down on that point and move on to a slightly different area, I talked about this wider story rather than the long list of KPIs, also thinking about more what these networks offer to society and as much making sure you don't miss out bits of society. I'm thinking inclusivity, I'm thinking adoption. How do we factor that into our thinking?
Well, we need to learn the lessons of what work has gone on beforehand. The government has spent a huge amount of money on doing various programs, driving the 5G testbed and trials program, which was a great sort of testbed to show the art of the possible, to prove the 5G business case was one of its ambitions, and then to show that actually these stacked use cases can add huge value, be it if you're in agri-tech or manufacturing or health and social care, tourism, whatever. And I remember March 2018, coming down to one of Dimitri's other showcases here on the coldest March day I have ever experienced in Bristol. It was snowing, and we're out in the Millennium Square showing augmented reality of what it could look like, the art of the possible in the future. And we still haven't got there, and that's the thing we need to learn again, is that it takes time for these things to embed, to develop and to adopt. And adoption of this technology doesn't happen on its own. It requires effort, and that's various events recently have talked about. It's not so much the technology, it's about the business case, it's about the mindset, and it's about the culture of adopting this stuff. And we tried to do it through the spending review in 2021. Other things were more important at the time. But here we are back again in 2025 talking about adoption, and the way this is going to move forward is to really start to think about how we can use this technology, the services and things we can provide to really change the way we do things.
So we maybe didn't fully learn those lessons, but we did fix the weather.
We did fix the weather.
How do you think about these different communities of use, Julie?
Well, I think it is important to look into these communities, not just because of fairness and nice things, but because this is where opportunities for new businesses as well. Yeah. So, for example, I was talking about this time last year to a bunch of people who were building robotic systems for precision farms. And precision farming is not just important because we can build new businesses there, but in honesty, we need to do precision farming because we won't get the food out of the soil to feed all the people by 2050. So, but they were building all these great innovations, but they could not uplink to anything. There was nothing for so that was their Achilles heel. We need to get rid of those Achilles heels because we're curtailing business. And we're also meaning that some people have it all and some people don't have it. And so we solve a lot of problems by solving these what seem to be soft problems.
So vast tax, Doug, I mean, how does all this discussion about inclusivity and adoption and maybe safety relate to building chips in this space?
Well, I mean, certainly, I don't know as much about, well, definitely to do with building chips. The point, picking up on the business opportunities for if you can solve a problem. I mean, having spent far too much time in venture capital-backed organisations raising investment, investors invest in solutions to problems. If you don't have a solution to a problem that somebody wants to solve, not a problem you hope that they have or a problem they didn't know that they had, but a problem they actually have. So that's why businesses are successful. And in this case, adoption, inclusion. Adoption, listen to the operators. Listen to the operators. The operators are saying they've got no money. It's all too expensive. It's too complicated. So there's no point doing 6G unless you make it cheap and easy for operators. Listen to the users. Users aren't saying, God, if only I could do a 3G hologram call. They are saying, I don't get coverage here. It's still rubbish on the tube, etc., etc., etc. So if you solve coverage once and for all, and you make it cheap and easy, and you spend the benefits of new technologies like AI in order to achieve those goals, then you've got a proper business. And chips are integral to that.
Yeah. Simon, I think Ofcom's done a lot of thinking on adoption and inclusivity, right?
Yeah, absolutely. I mean, it's obviously of what we do in terms of inclusivity, etc. And it is just about sort of echoing the points that all the panelists have made here in terms of making sure that you're essentially listening to the voice of the customer and the users of these technologies, and then feeding that into the requirements that sort of and the vision that sort of sets that out. And I think moving away from that sort of notion that it almost feels like it's almost like an engineering challenge with each new generation, where you're looking for X times higher throughput or X times lower latencies, etc. So maybe moving away from that mindset and thinking about some of the points raised by the panelists here is probably a good way to think about how you go about setting up the vision and the requirements for a new generation of technology.
Which takes some investment, right? So do we pay enough for that investment to happen?
In what sense? In terms of
consumer prices are really low in the UK.
They are, and I guess if you do look at sort of like the data. I mean, we produce our sort of annual sort of quarterly market updates and reports on fixed and mobile pricing, etc. And the ARPU for mobile usage in the UK, is pretty low. It's like the order of like £12, I think it is, the ARPU. So, for operators to be able to invest in their network, maybe they do need to think about ways in which they can monetize their investment so they can drive that ARPU up to levels which gives them more freedom to be able to do more things with their networks and make it available in more places.
Yeah, that's a very good point.
Can I come in there, Simon?
Absolutely.
Because it's interesting how it's very much consumer driven at the moment. And we heard this morning about the B2B piece not really kicking off. But from a consumer side for an operator, if you go back far enough, some of you will remember a concept of build minutes, which was a 2G concept where if you didn't carry a minute of traffic, you couldn't bill for that minute of traffic. So therefore, it was incumbent on the operators to build the capacity, to build the reach of their network so they could bill more minutes. Now, we've lost that with fixed price capped things where there is no incentive now to build networks that can carry the traffic, to have the reach and everything else, whereas the best model for an operator these days is if I can offload my traffic for someone else to carry it, I haven't got to worry about building that. And then it comes down to, I think the UK, sort of slightly controversial with Ofcom, could increase costs for users to pay, give the operators more chance to be able to build their networks and scale their networks, and just think about it differently.
Mm. Yeah, it's interesting though when you talk about the B2B side of things, and clearly operators deliver a lot of B2B services, but arguably their networks aren't tuned for the needs of individual businesses in special places. So perhaps that's the same technology, it's the same concept that's being delivered, but it may not necessarily always be delivered by nationwide operators.
Yeah, and then there is that growing, and the work that's been done through 5G is amazing about the sort of the not just consumer but industrial and sort of the private sector, private networks that are growing, and the release of the N77 band, for example, really make that happen. You could have spectrum outside of an operator. You no longer required an operator to be included in whatever you're trying to do, so you could build those networks and you can start to demonstrate. JLR is quite a good one to you show that one, where they've built these networks and they're starting to run their own private networks. So using that technology and that capability, and that's kind of where the adoption starts.
Yeah.
That's how that journey begins.
Very good. I'd like to pivot a little bit to another concern that the public might have around safety, and it may not be immediately apparent what we even mean by safety there. There was a lot of, I'd say, a flurry of concern around radiation safety. There was a lot of that around Bristol as well as other parts of the country. But I think when we're talking about these key value indicators and we talk about safety, we've got a more holistic view of what that sort of trust in the technology might mean. That feels like a very Ofcom question, Simon.
Yeah, absolutely. I mean, there are people in one of our sort of priorities is leading a safer life online. So that's very much related to this. And there are people in the online safety group who are a much better placed to be able to talk about all of the issues associated with that. But I think from the thing that I think we probably do need to be mindful here, though, is that as AI starts to play a much greater role in terms of how networks are deployed and how they're operated, etc. They're going to be consuming, those sort of AI native capabilities are going to be consuming a lot of network and also our own sort of like user data to be able to train those models to, tailor and deliver those services that people need, to be able to optimize the networks, etc. So I think having that sort of trust and trustworthiness and transparency in, in how that data is being used, how it's being used in the notion of AI, etc. And also, when things go wrong, I mean, the one thing that we are, intently, working towards is those sort of like safe and secure networks. And so, when network incidents happen, etc., how confident are we that, if AI has been at the heart of, design, sort of using data to then make a choice, take an action that's resulted in a consumer, a consumer sort of impacted incident. How confident are we that that AI capability is explainable enough so that it can be audited, so you can understand the root cause, so that then the necessary guardrails can be put in place so it doesn't happen again, etc. Appreciate that we're taking sort of greater levels of human interaction out of the equation here, which can be quite a big factor in these types of incidences. So they could be lower, but how do you make sure that those types of incidents that happen in the future can be understood and prevented in future?
Interesting, yeah. Feels like there's another aspect to safety, maybe for Doug, which is a link to resilience. In that, I mean, we've hardwired resilience and the network of network approaches into networks since 2G, and the emergency calls are handled across whatever networks you can sniff, not just your home network. How do you engineer that kind of resilience into future networks?
Heathrow Airport. Now, we haven't actually, there's going to be inquiries to find out exactly what happened and the rest of it, but never mind the cause. That one hub, the airport itself, goes down. Huge knock-on effects, ripples everywhere, because there's too much functionality in one place. Now, I think going forward, there's clearly trends because of the current style of deployment of AI to move to mega data centers where there's lots of server processing, there's GPUs in order to do certainly RAN functionalities and other functionality too. Those become single points of failure to reduce potential resilience, or make it open to attacks. Also, the fact that you've then got to keep hoovering up data and taking them across the network, from like the edge back to a data center and then back again once you've retrained models, et cetera, et cetera, et cetera. There's a lot of complexity you've built in there, a lot of attack points, and this, sort of a small number of highly valuable failure points. There has to be, and this is something that I think we looked at in the AI Expert Working Group in UK TIN, the need for distributed functionality is very important for both laws of physics reasons, because of latency from getting from A to B, but also from that resilience against network attack. And so I think that's and that flies in the face of the current trend to move everything to a data center and stack it full of GPUs approach to life.
Yeah, very good. Any other thoughts on safety, Julie?
Yeah, so can I just pick up on this point? See, I would argue what you've just said is the opposite. It actually gives you more resilience because it is inherently a distributed system and nobody sends their data to a single data center, and data center managers tend to be a distributed system. So the whole infrastructure is distributed. You've made a bad decision if you've gone down a single data center way. That is the Heathrow, sadly, way of doing things. But I think there's an awful lot of resilient compute research and solutions out there that overcome those problems, but not even to do with telecoms, to do with compute more generally, that have been tested before we put telecoms on it. Now, can you remind me of your question again?
That's why I think you're good. You've addressed it very well, very well. Anything else, Ian, on the safety front?
I don't think there's much else to add other than that. It's incredibly important, and with safety comes reliability and resilience as well. And as you start to push these networks out, people become more and more dependent on them. Take rural communities, and you're using healthcare or social interaction applications, and people become reliant on that. You have to make sure those networks are available, even at the edges and the extremes.
Fantastic. I want to pivot to my last question before opening to the audience. Ecosystem. We are an ecosystem here. There's people from all sorts of parts of the landscape, and out in the square we've got school kids coming in and having fun with turtles and so on. What are your thoughts, Julie, about the ecosystem we're creating and what we need to do in the future?
So my thoughts are, obviously, there's people like me who like to mess things up and be a bit rebel, but I can't do this on my own. I need operators, I need support, I need users, I need the kids out in the field, because we need to have that community together to make this all work. We have a problem with talent, and it's getting worse. And so we need to nurture that new talent in, and it's great to see today that we're getting people enthused. It wasn't somebody saying there earlier they want the school to have placements in with the university. I mean, that's exactly what these kinds of things are for. We do need that. We also need a better mix of humans. So in other words, we need the people with talents in the likes of machine learning to come in who may have not looked at telecoms before, but bring all that brilliant knowledge about resilience and things like that they have experienced. And we do need to listen to our users and our operators.
Brilliant. Ian, you have a reasonable claim to being Mr. Ecosystem in the room. What's the job ahead?
Pretty much what you described, I think. Yeah, no, it's absolutely right. It is an ecosystem, and some people don't like the use of that word, but it's exactly what it is. From the innovation at the beginning through to developing products and skills, spin-outs, operators adopting technology, users adopting the technology that the operators have adopted, people ultimately paying for it, and then shows there's investment in it, and you go round again. And that's what we do. And I think there's so much cool stuff going on in telecoms at the moment. And telecoms is not a very sexy title these days, and why do kids not want to get involved in it? Because it sounds boring. But I got involved in it because been around quite a few years, and it's always changed. There's always something new coming along. You know, we talked about 1G, 2G. That was amazing. You could sit in a lay-by and order a pizza. That was groundbreaking. Now, you can do so much stuff, people take it for granted. What's 6G, 7G, 8G going to bring to us that we don't even think about yet? That's what's cool about it. And as you say, bringing skills from other areas. It's no longer like old people like me who used to put twisted pairs together in a box and make the telephone work. It's about the softwareization of stuff and everything else. It's a different world, but it's an exciting one. But then it's an ecosystem that needs to work together.
For sure. How do we build that ecosystem, Simon?
Well, I mean, I think we've only got to look around what's happening here today and also in other parts around the country at the moment. When you bring government, when you bring academia, when you bring industry together, you know, you can do some fantastic things, right? And I think, you know, just so following on some of the points there, I mean, connectivity, communications, etc., is the heart of everything that we do in our daily lives and how we do business, etc. So, building those ecosystems, building that talent pipeline, ensuring that we have the skills coming through, etc., is something that we really do need to focus on that and make sure that we don't have any sort of slowing up in that process.
Great points, but I feel like it's been a UK perspective. Doug, I suspect your targets for your chips are considerably beyond the UK. How do you engage in that internationally?
They are. There is not a big enough market here just to make chips. I mean, what I was going to say is I think there are people on the panel who are being far too modest about some of the great things that have been gone on in collaboration. Things like Sonic, that has been a UK initiative, is a fantastic opportunity for people to come together and collaborate and solve their interoperability problems and what have you. So I think the important thing moving into a 6G world is that carries on. It's really important that that whole open networking thing that has started in 5G becomes, in at the start of 6G, not retrofitted afterwards, both in the standards and the collaborations that things like Sonic. I think another thing that in the UK TIN AI group flagged was the need for test beds or hackathons or whatever, where operators would open up things. And I know that's not their modus operandi normally, but to open up to third parties so that people come and test great new ideas that aren't necessarily to do with standards, they're to do with just things that you would put into a network which are AI-based, that need access to the data, to train the models, etc., etc., etc. So I think that's a thing that should be better in the future, and Sonic is a thing that should continue into the future.
Very good. So
If we only had something like that.
If only. Well, I'm currently doing the significant looks at DSIC colleagues in the room. Keep doing what you've been doing, whatever you do. Very good. Now I'm going to open up to the floor for any further thoughts on this. How do we make sure that the networks we're innovating in for the future actually deliver on something that society and industry need? There we are. Right in the middle here. There's the microphones on their way. This is a BBC question that's coming, so I hope the microphone's high quality.
It's the R&D question, which might be a bit vague and wondering. So I've been working on kind of 5G for the last few years, and a large part of that has actually been me complaining to my colleagues who are working in the standards that I can't buy the equipment with the functionality that I need to do some of the kind of new and more interesting services. And it's things like, sort of like, and also with the releases of the way kind of like the delay between kind of the standards and the equipment becoming available. And one of my colleagues told me that there's like this 80-20 kind of rule where 80% of the functionality actually in the standards doesn't make it into the chips. So, and at the same time, we've got lots of different industry kind of verticals who have sort of different requirements, but they're in a kind of chicken and egg situation where, well, actually, if I had these things, then I could do these things, and then I could basically kind of create a new service. And given this kind of this idea of simplification, which does sound a good thing and a quicker time to market, is how do we? One of the things I see as a difficulty is how do we collate what are the best things we need? Because each, in the bit I work in, it's all about kind of like the quality of service, the time synchronization, those sorts of things. But and that's across a few others as well. At the same time, you only get kind of individual voices, and we don't have that much of an impact on the standards or the chip makers. And I think if we can find a way of actually collating and basically getting to what are the most essential features, that is something we really need. And a difficult question I have for you guys is how do we do that?
Yeah, so real tension between the diverse range of needs that different communities could adopt and the less is more simplicity that Doug's calling for on the chips. Thoughts, folks?
See, part of the problem is that if you make a complex SoC, it needs to have some hardware bits, it needs to have some software bits, it might need to have some AI bits. But ultimately, you have to dial up to get the right compromise of costs and power and all these good things. So you'll try and keep as much in software as possible. So somebody could make changes to the firmware and do specials. But in general, what's in the hardware is in the hardware. It's very expensive to make chips, and somebody once said it's like selling ceramic tiles. You sell by the square meter. You've got to ship lots and lots and lots to recoup for, tens of millions of dollars of cost in design, tape out, qualification, and the sheer cost of making the chips themselves. So it's difficult unless you can do something that's either applicable to lots of people, or it's something that you could do in software and you've got the wherewithal to change the firmware. That's kind of where we are, and probably why you're seeing the problem you're seeing.
I guess clubbing together with other people with similar requirements and buy more chips would be one.
Yeah. Buy lots of chips or write a big check.
Other thoughts, anybody?
Well, the softwareization is one of them. But also, I mean, it's not going to answer your problems now, but we're getting cleverer with manufacturing as well, and allowing more tailorization in manufacturing where it still becomes cost effective. But it won't answer you tomorrow, but it might answer you in 10 years' time.
I'm not sure I recognise the clever manufacturing you described. But
All right, okay. Keep an eye out.
Any other questions? Keith, yeah, just at the front.
Thank you. I'll try and phrase this distinctly. I mean, it seems to me that a lot of the potential for commercializing research we see in the Square and everywhere else in the country rests either on the telcos being able to completely change their business models to free up investment, or on investment coming from somewhere else. So a big 6G question would be, can either of those things happen?
That's a great question. Feels a bit Ofcom-ish because the market structure would be very different in that scenario.
Yes. Yeah. Very good question. Come back to me on that one.
Yeah. Well, what has Ofcom done to encourage and enable private networks?
Well, of course, yeah. I mean, liberalisation of spectrum, so creating frameworks so that people, can gain access to spectrum, for example, in the 3.8 to 4.2 band, etc., to then be able to go away and, develop their own private networks to meet their own enterprise needs, potentially offer private services to local communities, etc. So all of those types of, spectrum sort of enablers are sort of there, and, we're continually looking to see, how that can evolve into the future. I mean, one thing that we've not spoken about here, I guess, in terms of 5G in particular is the use of millimetre wave. And so, there is the process of sort of auctioning, well, actually, it's a combination of auctioning millimetre wave in sort of the more sort of dense urban sort of areas, and then having a more of a shared sort of access license-based approach in those. So not in sort of in the more sort of rural parts of the country, or sort of outside of the urban areas of the country. So that access to spectrum is definitely an enabler for sure. Yeah.
Nice one. Nice. Very good. And I mean, Doug, I'd seen a lot of UK innovators have actually, the market has sort of naturally followed that wider range of demands, because there's a lot of selling into private networks, into emerging NTN networks and so on. So do you see that need?
those are certainly areas that have shown some decent growth, and clearly are opportunities that will help pull in investment.
Yeah.
So I was going to follow up on the millimetre wave. You've got millimetre wave basic function communications, but when you bring sensing in, there's a whole lot of new markets there. So there might actually be other returns on investment in that regard.
Super interesting. Yeah, I mean, actually, that's not spectrum for more bandwidth. It's spectrum because you get a greater spatial and temporal resolution. There's a much more, fundamental physics reason for that.
And you can do more with it, yeah.
Yeah.
Yeah, and it's that freeing up the spectrum, isn't it? It allows, back to the use cases, different people to build the use cases. You're not incumbent on an operator thinking that's a good idea for their business to adopt it. You can start to drive that adoption. And when I spoke to investors, as I'm sure many of you guys do, they sort of say to me, the infrastructure networking bit is interesting, but actually, I think the real value to invest in is on the use cases, because they're the things that can really scale and really start to generate a return.
Fantastic. Now, there's so much more we could explore, but I've had the winding up notice. We've covered a very large range of areas, and thank you to my panellists for being good sports and taking the questions I've hurled at them. Please join me in